Hello guys. Uh, Today we are going to solve this longest substring without repeating character problem. This is a LeetCode problem, and we are given an input with a string, and we are asked to find the longest substring without repeating a character. So, for example, here this example, right here, I can see ABC is the longest substring, and then I have ABC. This is the longest substring. This is a substring, and the longest means this is the longest part of this string without repeating a character. This is what this algorithm wants. Uh, Example 2. This is a string, and if we break it into any part, we will see that even if we add one more b, we will be repeating characters. We cannot use any extra string. That's character. That's it. And so it's the longest will be just one. And in this example, the way I solved it was, we are given this string. This example one, right? The way I did was I started from here, and I can see this can be a string, so I put a space there. Then now I start from here. Now I see this can be another string, and then itself CB can be a string as well. CB can be a string as well. CB can be a string as well, but we are looking for a longest substring without repeating a character. And the way I approached the solution was, my thinking pattern in my brain was basically I started from this point, and then I kind of slided into the window of ABC. Then I started again another sliding pattern from here. So this is what I can see, right? And so let's take one more example. Example 3, right? Example 3. So, oh no, I didn't want to submit that. Anyways, so here I start from here, right? PW is a substring. I can take that PW. Then I can take WKE, and then I can take, yeah, that's it, KEW. Another is I can take KW, but no matter what the what longest substring we take, it's just this answer is 3. So the way we can solve is basically we observed a pattern, that is we started from a pointer, that is we start from an index, then we kind of slide our way through to find our longest substring without repeating our character. Algorithmic approach called sliding window technique. Sliding window, and the framework for that is basically you have your left pointer, or you can also call it start, left or start. Let's use start, and then you have your end, which is going to be another end of, this is the start of the window, and this is the end of the window, right? And this is how we formed it. If your counter increases or decreases based on a given pattern, you normally use let's say end is less than what is this input called as dot length, right? This is normally you normally use while in the sliding window when you increment or decrement your counter based on certain condition, right? Here if we see a repeating pattern, then we might want to slide the window. Basically our window might become invalid if we see a repeating character. So maybe we want to squeeze our start further, and we want to keep our right at the fixed position, which basically squeezes our window into a smaller frame, right? And depending on another condition, for example, our current substring is valid and we see one more character which is still valid. In this case, we want to expand our end to a little further position, right? And basically there is a condition we see, so then we're going to use a while. And another is you can also use a for loop, but here we don't have a condition to increase the index of I, right? It increases unconditionally no matter what in every iteration. So we'll just stick with the while loop. Another is here, since we are dealing, so, and this is also a framework, you can assume it as a framework. We are either increasing the window or decreasing the window. So that is what this if else statement is. Here, what is the condition, right? We can see we need our solution without repeating a character. So that means we need somehow a mechanism to record our characters, right? If we see a character that has already been addressed, then in this case maybe our window has a chance to become invalid. So we also know that we need a unique, maybe we'll yeah, we'll just call it a unique set, right? We have not, let's say we have never seen it, if never seen before, if never seen before, our window is valid, our window is valid, we keep on expanding. But if our window is not valid, right, if we see whatever we have seen before, then we want to remove that. Basically we want, so if we have seen, or if we saw something that we already saw, then what happens is we might want to erase what we have seen before, and then with the given current character that we are seeing currently, we want to take that into account. So for this rule to be valid, we don't want two repeated character in the same window. So what we'll do, we will remove the original one we saw, and then we'll expand it to the one we are seeing right now. So this is what it does. We want to remove it from window, and this is how we want to keep going, right? So if I take this pseudocode and then develop an algorithm, this is fairly simple. This literally, this will turn out in this code. So we'll need a start equals to 0, and then we'll maybe do a end equals to 0 as well, because this is a sliding window technique where we have two pointers that slides and forms a window. And this is what I'll do. Maybe I'll just continue here. And we also need, you want unique set of characters, because we are dealing with a constraint that is basically we don't want to repeat the character. So unique equals, maybe we'll do a set, right, to store a unique character. And we want to return what? We want to return a longest, that is maximum longest string, maximum longest string length, right? And we'll initialize it to 0. So this is again given by the framework of sliding window technique, where I say you take the window where this window can either expand from 0 of the index to end of the index is less than, end is less than or equal to the, what is that, the as given to us, as dot length, yeah, as dot length. And so this is the condition. We are given this string, right? If we are given this string, we initialize our start and end here at this point. So if we keep on going, do we want to meet our end with the end? So all the way to the end. We might just want to go to the one step, second last, up to this point, right? We don't want to transfer to all the way to this peak. So maybe I don't want to do this, where end is less than s dot length. And now, so here, right, we want our window to be valid. That means we don't want a repeating character. So that means if we have seen, if we see a character that has never been seen before, then we take it into the window. So if this unique set we have does not have this currently processing character, that is and is our current index. So basically that's what I'm using here. Then we want to process it. Else, what do we want to do? We want to, else we have our window invalid. So this is what happens. Now let's first process that element, the unique element first. If the element is unique to us, what we want to do? We want to keep expanding our window. So that means maybe we want to say this unique dot add, yes, add as in, and then maybe we want to update our max LCS. So basically max LCS is the longest window, length of the window, how long the window can be for the valid solution without repeating characters. So max equals to max dot max, the maximum of either current max, which is max LS, or the length of the window is given by end minus start plus 1 to include the both side, both basically not just the distance, but to have this end and start both inclusive for the solution. And then finally what we want to do is we want to expand our window. Since current window is valid, we want to expand it to one more on the right side. So basically end inclusive, right? But now if the window is invalid, what happens? We basically want to remove the previously seen character. To make the solution still valid, we either have to drop the current character we are seeing, or we have to remove the previously seen character if it's repeated, right? So this is what I'm gonna do. We have to drop it. So basically, unique dot delete, what is that, s dot start. The previously seen character needs to be deleted, and that is given by this s dot start. And then we start, basically we squeeze the window to make it still valid. We drop that repeated character by dropping the previously seen character at the start of the slide and at the end. And after we do this, we just return the max ls. So this is fairly simple. So all I used was the framework of how sliding window works, and then I tune the if and else statement to make it valid. So now let's run it. Okay, now this is a valid solution, and this is how it can be solved. And if we discuss about the complexity, right, the space, there's no new so here we have initialized a new set. In the worst case, all the element can be a different element. So this can expand all the way to the length of the given array, and that's the space complexity. And the time complexity is basically we are iterating all the way through the array. So time complexity is also of O1, O of n, and same for the space complexity. So this is how it can be solved. And the same technique can be used for solving different problems that has to deal with the substring.